Hi, I'm Jonathan Parker, and today we're going to talk about breakdowns, breakdown prevention, and a little bit about the most commonest causes of breakdown. The problem is, at the moment, so many people are using their boats for the first time in quite a few months, and of course people haven't necessarily left their boat in a state beforehand that they knew they were going to leave it for a few months because of the lockdown and various other reasons. So when you first go to your boat now, you need to really look closely at the engine and also do regular checks from now on, just to make sure that there hasn't been any long-term damage through leaving the boat without proper care like you would normally have done. So we're going to talk today about the most commonest causes of breakdown. There's been quite an influx of breakdowns these past couple of weeks since people have been let back on their boats and able to use them, and most of them are related to lack of use. So I think the best thing to do is just talk quickly about the commonest causes of breakdown and go from there. So a little bit about myself, just so you know who you're talking to. I've actually been teaching the RWA diesel engine course for about 6 years now. And I've formed the company Parker Marine Services really to give people peace of mind at sea by teaching them how to look after their engines. And I've had about 20 years experience of working on all types of engine, and in that time I spent 10 years doing marine breakdowns, and I estimate I attended about 3,500 breakdowns in that time. And most of them we tended to find were preventable. About 93% of the call-outs we went to were actually fixed on the scene. And that's quite a big number. But most of the reason why was basically because you could, with the right spares and just a bit of knowledge, you can actually fix them at the scene. But most of them could have been prevented in the first place. I've also appeared on BBC Sea City series. It was a series a few years ago, and I was in the first series, and I was followed around by camera whilst doing the breakdowns, and it just shows a bit of what I used to do. I've also been an advisor in the production of literature, including one of the stress-free series of books. Duncan Wells, the author, he's written several books in the stress-free series now, and stress-free motorboating was one that I helped him develop. So I'm quite proud of that one. But going forward, so the most commonest causes of breakdown are really overheating, electrical problems, fuel problems, and then foul propellers. We do have mechanical failure, but it's normally caused by one of the previous four reasons. So the first thing we'll talk about is actually overheating. Now this talk's going to be about 20 minutes, so we're going to just basically go over the basics and the most common causes of these breakdowns. And the first one we're going to talk about with regards to overheating is actually the raw water side of the system. Now I'm not sure if you're aware, but most engines, marine engines, they actually use seawater, raw water, to actually help cool the engine. And in some cases the raw water actually comes into the engine, goes around all the engine internals and exits via the exhaust pipe and mixes with the exhaust and comes out the back of the boat. And this is called a completely raw water cooled system. Now the other form of cooling is when the raw water pumps into the boat, it goes through a heat exchanger and then goes out the exhaust. So your engine actually instead has a second cooling system as well, which is an antifreeze coolant mix. That is pumped around the engine using a circulation pump, much like any car that you would drive. But your car uses a radiator with airflow to cool that coolant down, but we don't have that on a boat, so we use a heat exchanger instead. And within that heat exchanger there are lots of cooling tubes, and the raw water is pumped in, goes through the tubes, making the tubes cold. When the engine heats up, the antifreeze is released into the heat exchanger, and the cold tubes transfer the heat through that, so it exchanges the heat and cools the engine down. So a heat exchanger is a form of radiator. So it much protects the engine from internal corrosion, so you don't have raw water going through. But the biggest pitfall with this is actually the raw water system itself. And the problem is we're not in control of what's sucked into the engine. So we do have things in place. So the most common thing that we'd have in place is some sort of raw water strainer. So we'd have your seacock skin fitting, sail drive, stern drive, and then there'll be some sort of filter system to take out the debris. And this is the most basic sort of kind. It basically has a lid you take off and then a metal gauze inside, and this traps any larger pieces of debris that come through. And you can see the metal gauze isn't a fine filter or anything like that. So anything bigger than these holes is deemed that once it gets through the system, it'll get through the heat exchanger and out the exhaust. So this is the first thing we check if we suspect we have some sort of raw water blockage. But also we need to regularly check this. And if you've not been on the boat for a while, you need to check it to see if there's anything in there now. And I've experienced different things in here, and through lack of use I've actually seen crabs that have been growing in here. I've seen eels in here, so there is wildlife that will actually get in here and can cause problems. Hopefully you've all had your seacock shut, so it shouldn't be the case, but if you have left it open because you haven't been able to get to the boat, then you need to be checking this for any contamination. Also, even if you've had the seacock shut, you should be checking it before you do any journey and making sure that there's nothing in there that can cause you a problem to start off with. Now, if you do have an overheating issue, before you turn the engine off, the very first thing you should be doing is trying to decide whether it's a raw water problem or a coolant problem. So the most common cause, like I say, is a raw water problem. So the first thing you do if you've got a yacht or something where the water you can actually see coming out the exhaust, you should, just before you turn the engine off, is just check for that water flow. If it's not there, then we know the raw water system is causing a problem. If it's a much diminished than what you normally expect, then again, it may be there's a restriction in the raw water flow. So we need to firstly check the strainer once we've turned the engine off, and then go from there. If we ignore the alarm going off, or nothing tells us that the engine's overheating and we do have a blockage, we can actually damage this part of the system. Now this is a raw water pump. It's driven by the engine, and basically the raw water is sucked in, and this is a self-priming pump, so it physically sucks the water in and then pumps it through the system, out through the heat exchanger or around the engine and into the exhaust. Now, because it's a self-priming pump, the actual pump blades, which are made of rubber, actually have to have contact with the outer housing, and because of that contact, it becomes a problem if there's no water going through, because it's purely cooled by seawater. So a good impeller, once we take it out, it should actually have very straight blades and not bent at all. And they should all be intact, of course. But the problem is, through heating, the actual blades can become bent because they get hot, the actual rubber changes shape and then sets in this bent position. Now the trouble is, once they end up in this bent position, they no longer contact the edge of the pump. So the water, how one of these operates is the water comes in, it gets trapped between the blades, and then there's a cam here, and then the cam bends the blades over, and the water can no longer get beyond there, so it pushes the water out. And if the blades are already bent, then the water won't trap between them, it'll just keep flowing over the top of the blades and you won't get any pumpage, and so it won't pump the water around. In more extreme cases, the actual blades can fall off. There's a couple of blades missing from this impeller, another different type again. It's actually the same impeller that would go into here. And of course, if they fall off, we need to find out where they go. Because if it falls off here, then the trouble is, once you put a new impeller in, the broken blades will travel up the system and then could get caught in the heat exchanger. Now let me show you a heat exchanger. This is the internal part, so the cold tubes, the tube the raw water goes through and makes the internals of the heat exchanger cold. It looks like this. Then we call it a tube stack, and it's lots of tubes, and the raw water travels in one end and out the other. Makes the tubes very cold, and so the antifreeze then gets dispersed over the top within a casing when it's required, and the tubes transfer the heat and take the heat out of the coolant and cool it down. And the trouble is, impeller blades can easily block the end of these tubes. So we need to be careful that the broken bits of blade are found, and they normally, because it's a lack of water that causes it, they normally go the way of gravity. So for example here, if the blades break off, because there's no water going through here, they won't actually go up the system. They'll only go up the system if you change the impeller and don't find them. They're more likely to have gone down the system. So they might be in this elbow beforehand or in the bottom of here. So it should hopefully be obvious. They can also get jammed in the hole. So we need to be checking both sides anyway, but also particularly if we can't find them, just down below the impeller itself, because they'll fall down the way of gravity. So the ways of preventing this happening in the first place is actually doing regular checks of the seawater strainer and regularly changing the impeller when it's required. So the impeller doesn't get weak, it has good suction, and the strainer is always clear. If we don't check the strainer, or we do have a problem and we do get a bad overheat and the impeller's damaged and you've changed it, there's one other part of the cooling system that you really need to check, and it's the exhaust system. So the exhaust normally is made of a rubber hose, and it's a bit more of a problem on yachts because you have a long length of rubber hose that goes from the back of the engine all the way then out to sea, and those lengths of hoses can be 2, 3, 4 meters long, and in that exhaust hose there's an awful lot of water that gets pumped through, and of course your engine is quite low and the water line can actually be higher. So when we pump the exhaust out, it actually has to go up and then out above the water line. And the trouble is, once we turn the engine off, that water can make its way back down the exhaust, back up into the exhaust pipe, into the exhaust manifold, and get back down into engine internals on top of the pistons. And the trouble is with that, it'll actually cause you next time not to be able to start the engine. It'll be called hydraulic locked, where water builds up on top of the piston and the engine can't physically turn over. And so what you have in place for that is what we call a water locker or a muffler. And that's actually fitted as the exhaust pipe comes down in the lowest part of the exhaust system before the pipe then travels back up to go out to sea. And quite often they can be made of rubber and plastic. And the plastic ones do have more of an issue with a lack of water flowing through, because then you've just got the hot exhaust. And the hot exhaust can be 700-800 degrees. And the actual unit is only rated to 120 degrees. So there's an obvious problem there without water going through. So if you had an overheat, and it is the raw water system, firstly, before you even do anything, just check your exhaust. Because if it's melted, we're checking the muffler for any damage, any visible damage to the exhaust pipe. And if it's melted, then of course we'll need to change that before we can actually do any other repairs. So if you don't have a spare exhaust pipe and muffler, there's no point changing the impeller, because the first thing that will happen if you get the system going again, you'll get water and exhaust flowing out of your exhaust system into the bottom of the boat, and we don't need that, do we? And also we need to check that system. Once it visibly looks okay, we do our repairs, we change the impeller, and then once we get the water pumping again, we then check the exhaust again, because there could be damage to it that you can't visibly see, but once it starts flowing through and there's some pressure in there from the exhaust and the water, then it will obviously start coming out, so you'll be able to see. So check before and after your repair. Now, there's lots of other things that can cause overheating, but that is the most common. So that's what we're going to talk about just now. So the next form of breakdown that is very common is electrical issues. So electrical problems are very common because there's quite a lot to the electrical system. There's lots of things that can cause problems. But really, from a preventative point of view, the best thing you can do is keep electrical connections clean, dry, and corrosion free. And most problems actually stem not from the engine wiring harnesses, but actually from the supply of power from the batteries to the engine itself. Engine wiring harnesses are normally quite well made, they're quite well put together, they're insulated, and you don't often get problems. The only common problems you really get with engine wiring harnesses is if they're not tied onto the engine properly and they rub through on a metal component and rub through, or the wires flex so much that they internally break. Corrosion again is another issue. So if you do have sensors with the wires attached to the end, we need to keep them clean, dry and corrosion free. But by far the most common causes of electrical problems is actually batteries, the battery connections, battery switches, so we switch the batteries on and off with, and the connections onto the engine from the battery switches. Now, these quite often can get corroded, they can become loose, and quite often people use them as points to supply power to other parts of the boat. So you get quite a lot of wires piled up onto one post and they can work themselves loose and corrosion can go right through them. So we need to check electrical connections and also batteries. Now, battery maintenance is something that you should be responsible for. When you get your engine serviced, maybe it's a good idea to double check once someone serviced it for you that the batteries have been checked, or certainly request, don't assume that they're going to do that. So I'd certainly say, can you test my batteries? And there are sort of battery testers out there. I've just got one here. This is actually a battery load tester. And it's a very simple device. It's basically just a big heating element with a gauge on here, and we put a positive crocodile clip on the positive terminal and a negative crocodile clip on the negative terminal, with the terminal disconnected from the battery, and it will read the voltage, and then all we do is we flick a switch and it puts a high load to the battery, and the needle actually reads the condition of the battery. It sees how it copes with that load, and if the battery is good, it will hold the load there quite happily. If it's poor, then the needle will drop down to indicate that it can't hold its load. Now, quite commonly, one of the causes of a battery not holding its load isn't the fact that it's old and it's diminished. It's the fact that the fluid levels inside have actually dropped. And some batteries, you can check the fluid levels in them. So if you've got a battery whereas they've got caps, and a 12-volt battery will have 6 caps, because a 12-volt battery is actually 6 individual cells, so 6 smaller batteries put into one. So you have 6 holes that you can top up. And if you can top them up, you don't top them up with sulfuric acid, which is mainly what's in those cells. The electrolyte is actually an acid and quite dangerous. So before you do anything with a battery, you need to actually wear gloves and eye protection. But if we can check them, we actually check the level. There's always a minimum and maximum mark, believe it or not, on the side of the battery to tell you the level. And we need to make sure that we top it up to the maximum mark, but not too high. And we top it up not with acid, we top it up with deionized water. And in doing that, actually we're not diluting the acid as such, because in the charging process it converts the water back to acid again. And so it works quite well in just topping up with deionized water. But at the same time, we don't want to overfill. In the normal charging process, the electrolyte actually gets warm and warm fluid expands. So we need to leave a gap in the top of the battery for that expansion. So again, we only top it to maximum, but with gloves and eyewear on. A lot of batteries though are sealed. Now most batteries are sealed now, and you can't do this. And the problem with that is you then can't top up the fluid, which means that if the fluid does drop over time, then the only thing you can do is replace the battery. There is normally an indicator on top of the battery to tell you the condition of it. And it's normally the formula of a small circle on top, like a glass eye, and it has different colours depending on the condition of the battery. And it will normally say on the battery itself what the colours mean. Generally, it's always green. For a good condition battery that's fully charged, and then it will change colour to tell you that it's discharged, and it will also change colour again to tell you that it needs replacing or testing. Normally when it says replacing or testing, that normally means the fluid has dropped significantly, so effectively you need to replace it. But battery care is something you need to keep an eye on, and keeping battery chargers constantly charging a battery isn't a bad thing, because battery chargers nowadays are smart. Most battery chargers on boats will only monitor your batteries, and then if they detect it dropping down, then they'll turn themselves on and charge them back up again. But generally that can disguise the fact of a faulty battery. So every now and again it would actually pay you, once it's been charged up, is to turn the charger off and make sure all your batteries are isolated, and then just leave it for a few days and then check the battery voltages. And they shouldn't have dropped. So a fully charged battery is 12.6 to 12.8 volts, not 12. And in fact, a discharged battery is 11.9 volts. So what we're looking for is it to hold at 12.6 or 12.8 volts with nothing charging it and completely isolated. If it drops down significantly by about 0.2 or 0.3 of a volt, I'd suggest the battery is diminishing in power, and you would consider replacing it. I know it sounds like a very small amount, but that is a difference between a faulty battery and a good battery. You should hold its 12.6 to 12.8 for 6 months before you should start seeing it drop. And of course, remember, that's with nothing draining it at all. So electrical is an issue. It is the common call out. The other common problem we have is battery switches. Now the battery switch, lots of different forms. They can be dial switches where you can have a choice between number 1 bank of batteries, number 2 bank of batteries, and link them together or have them off. You might have individual on and off switches for the batteries. And in some cases you might have small soft buttons which then you'll hear a loud clunking in the engine room, and that's them electrically turning on a high power solenoid to electrically turn on the battery switches. Now the most common thing I find with the battery switches is that the connection of them turning on actually loses that connection, and that happens because just before the 2 metal plates inside a battery switch connect, there can be a small spark if you've got ancillaries already on. And that small spark then creates a bit of carbon deposit, and that builds up, and it gets to a point when they come together, there's so much carbon in between, you lose that electrical connection. And because of that, then the battery switch no longer connects. And what it can do is actually connect a small current, but when you go to turn the engine on, you might even get a reaction from the starter motor like a clonk, but then all the power disappears to everything, all the ignition lights go out, and you've got nothing there. And that normally is an indication that you've got a bad connection somewhere. So in that case, a battery switch is a good thing to check, and you can literally check if you can get to the back of the battery switch, the power, when it's on, you should be getting 12 volts to the back of both terminals. And of course, if you're not, then the battery switch is faulty. So a good way to prevent this happening in the first place is actually making sure that everything is off on the boat before you turn the battery switch on. So this normally coincides with leaving the boat. So when you leave the boat, make sure your fridges, your lights, everything is off by individually turning them off, and then turn the battery switch off. So then when you turn the battery switch on, when you next come down, it's not drawing any power straight to it, so you don't get the spark. So your actual battery switch will last a lot longer. And the other problem that we get is identifying what the actual electrical problem is. So when you come down to the boat and you go to start the engine, you may get your ignition lights come on, and like I say, you may just get like a clonk from the starter and then everything goes dead. That normally indicates a bad connection somewhere. So straight away I'd be checking the battery terminals, I'll be checking the battery switch and the terminals on the back of the battery switch, and then I'd be checking the connections onto the engine itself. There's a negative connection which is either fitted to the engine block, normally hidden away maybe on the side or at the back of the engine, or on the back of the starter motor, depending on the type of electrical system. And the positive connection always connects onto the starter motor. Now this is a starter motor, this is the electrical motor, the big cylinder at the bottom, and this is a starter solenoid, so basically an electrical switch. And inevitably, always, the main battery cable actually attaches onto the solenoid, and then the ignition actually then feeds from here up to the ignition for where you turn the key. So this is actually a point of a junction of electricity. So this isn't only just powering the starter, it's actually providing power to the ignition switch, which provides power to your instruments. And so this connection, because the engine wobbles and rattles, the actual wire that attaches on here can work itself loose. So this can become a problem. So we need to check electrical connections on here, the battery switch, and on the battery itself. Now the other issue that you can get is when you go to start, you get a loud rapid clicking, where you go click, 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 click. Now that's normally an indication that actually your battery is low in power. And if it's low in power, what will happen is the solenoid will cut in, so it will go click. It hasn't got enough power in the battery to turn the engine, so the battery level drops, and because the power goes, this then turns itself off, so it goes click, and then because it's now disconnected from the engine, the actual voltage comes up slightly, enough that the solenoid can operate again, and it will go click, hasn't got enough power, click, then it will go click, 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 so you get a rapid, almost like a machine gun effect, and that normally means there's a low battery. So that's what I'd be looking for in that case. But again, keeping regular checks on all your electrical connections and making sure your battery condition is good and replacing when you think it isn't will prevent a lot of electrical problems. Right, so going on from there then, the next common call is actually fuel issues. I've got a few more props here I can show you as we go along. And really when we're talking about fuel, we need to firstly look at how we're storing it. Yes, storing it, because we actually store fuel on a lot of our boats because we don't use it regularly like we do a car. With a car, generally every month we get through our fuel, we're turning it over and putting some in. But if we're actually storing it, say we have a yacht with a 200 litre diesel fuel tank, and we can actually get through either 1 or 2 full seasons on that amount of fuel because we don't use it very much. And the problem with that, we're now storing diesel, and we need to look after the diesel. So the problem with diesel is that it has an inherent bacteria within it that if left, it'll breed, the bacteria will get bigger, and even an algae and a fungus can start to form within the diesel itself. And that will drop to the bottom of the fuel tank. And if there's any water or moisture in the bottom of the fuel tank, it'll actually make it hundreds and hundreds of times quicker in growth. And this forms a product that we call diesel bug. So this diesel bug will form within the fuel tank, and it can actually, this is diesel bug here, and this was actually pulled out of a fuel pipe that goes into the fuel tank and is actually sucked up into the pipe and blocked it completely. So it can form into very large lumps. So we have to look after the fuel. And one way we can do that is actually stopping moisture from getting into the fuel tank in the first place. Now the best way we can do that is actually making sure that the fuel tank is kept full. If we keep it as full as we can, it's actually the air space within the tank that will condensate, and you'll get condensation on the surfaces that are exposed within the fuel tank. So the fuller the tank, the less space there is to condensate, so the less water will form. The other common cause of water is actually the fuel filler cap, and the fuel filler cap is actually normally fitted on the side decks, on the back of the transom, normally somewhere where every time it rains, water falls over it, every time sea comes over it, goes over it, and the cap itself just has a rubber O-ring to stop water from getting past it. If the rubber O-ring wasn't there, it would run round the threads and into the tank, and that's what can commonly happen, and of course it not being tight enough. So one of the first things I do is take the cap off and check the rubber O-ring is in good condition. After about 5 years, they do tend to start to perish and you see little hairline cracks in them. And very soon after that, you'll tend to find as you undo it, it'll drop off and fall into the fuel tank. You won't even notice, and now you don't have a seal on there. So I'd certainly check that, and it's a good preventative. If you take the cap off and there is no seal on it, and you haven't been near the boat in a few months, I'd suspect there's probably water in the fuel tank. So the next thing to do would be to try and find out if that's the case. If you have been running the engine in that time, then we need to actually then check the fuel water separator. Now the fuel water separator can actually be in different forms. This is a very common one. This is a CAV type one, and this actually has a bowl in the bottom to collect any water. This can be a glass bowl as well, so it may be more familiar if it was a glass bowl. On larger motorboats, you can get a different type. So this is a slightly larger one, but again it has a glass bowl, so you can actually see the water and any dirt that's collected in there. But all of these will have some sort of drain on the bottom to actually drain out any water. So what we do, we put a container underneath and loosen the bolt, and then we'll let the fuel come out. And if it's nice clean fuel, there's no water in there, but if there's water in there, it'll be at the bottom, because water is actually heavier than diesel. And let me show you. This is actually red diesel with water in the bottom. And as you can see, if I give it a swirl, sat on top of the water and at the bottom of the diesel is actually diesel bug. So that's been in here, and it's been growing quite well in here for a while. But we can actually see the water separation, and water will separate immediately with diesel. And I can show you that now if I mix it like that. As it goes back, you can see almost straight away it separates. So any water in your fuel will be at the bottom of the tank. And if the bacteria starts to grow, it'll actually sit on top of the water, and the oxygen in the water will actually promote the growth of it as well. So if you've had any water in your fuel tank, it'll actually go rife. And so we need to prevent the bug from forming. So the first thing is to stop water getting in there. The next thing is to treat it. Now, I have another container of fuel here, and this fuel is actually the same. Your right, my left, this one I've actually treated with some fuel conditioner, and as you can see, it's a lot clearer than the other one. So any bacterial element to that has been killed off, and so we have no bacteria growing in there at all. But what there is in here is bug in the bottom. Now this bug was actually put in there, if you can see it just there, before it was treated. Now an important thing to note is not all fuel treatments actually break down the bug. They actually prevent and keep the fuel in a good condition, but they won't break down the bug. So it's a preventative, this treatment. So the fuel treatments, there's lots of different types you can get. Some specify that it will break down the bugs, some won't. It actually says on there you need to remove any lumps, remove any water, and then it's a preventative. And so I treat this as a preventative, and in case you do have any bug, then you really need to get the fuel tank cleaned out, and then make sure then from then you look after it. If a boat's new to you, or you've not used it for a long period of time, I'd always think that there might be some growth in there. So first of all, what you would do is run the engine on the pontoon for a good 10, 20 minutes, and just then turn it off, and then just check the pre-filter, and then drain some fuel off and make sure there's no water or any debris in there. And if you've got a clear bowl, you can see quite happily if there's any water in there. The CAV type ones, which I'll refer to back again, the way these filter, you don't actually get the debris in the bottom, you only have the water separation. These type of filters actually filter through from the top. And I'll show you another one here. That's it out of the housing. And if I turn it up, you can actually see the bug actually collecting on top of the filter. So the fuel comes in the top, goes through the filter, and then out the bottom, and it's thrown to the sides by the shape of the perforations, and then the water will stick to the side walls of the bowl and then collect at the bottom. So the only way you'll know if you've got bug, if you have a CAV system, is actually taking the filter off. But if there is no water in there after just running on the pontoon, then you can suspect you may be okay. But of course, as we know, as you go out into a choppier sea, the fuel can get churned up and moved around, and there could be pockets of bug or water in other parts of the tank, and then that's when it normally gets collected in the fuel pickup lines. So I'd certainly be cautious the first time you take the boat out and not go far, and then come back and then recheck again quite soon afterwards for any water or evidence of bug. And again, after that, if you're clear, then you can do a longer passage and do the same thing, and just get into a regular check of that would be a good idea. And then by the time you then get to the end of the season, you get to your next service, then that's a good time to then take it apart and just really check for anything that's in there. And if it's perfectly clean, or very little contamination or none at all, there's no lumps and bumps in there, it's just gone a little bit darker, the element, then we can say yes, your fuel tank is in good condition, and then it's just a preventative measure. If you are having problems, you really need to get the fuel tank cleaned out. Now the biggest problem that we see is actually the contamination of the fuel, but also it's actually human error. Now quite often these filters will get changed, and the change should be every 100 hours or every year as a rule of thumb. And very commonly, especially on this CAV type filter, the seals can actually be ill-fitted or fitted incorrectly. They're quite fiddly to do, and they're quite hard to do because of the position they are within the boat. And so sometimes you can actually, these can actually cause problems. So we have to be careful if they're ever changed, that we actually make sure the seals are fitted correctly, and we need to almost double check. So be very cautious whenever you do change these that the seals are fitted correctly. If not, what will happen is the engine, you'll find it difficult to get the air out of the system. We call bleed the engine. So that's always something you have to do with a diesel engine. Once you've changed the filter system, it's full of air. We need to get the air out. So we bleed the air out using a lift pump on the engine itself. And they come in different forms. This is a mechanical one, and this is actually bolted to the side of the engine block, so the very side of the metal part of the engine, and a shaft internally pumps this, and that sucks the fuel from the fuel tank. So the thing to remember is the engine sucks the fuel from the fuel tank. Fuel tank hasn't got a pump in it that pumps the fuel to the engine has to suck it. So if there's any weaknesses in the filters leading up to that pump, then say the seals, it will suck air in rather than leak fuel out. So the engine will peter out and cut out. So we need to be really careful that the seals are put in correctly. It's actually quite hard to spot an air leak. And the only real way of actually finding it is normally you turn the fuel shutoff off on the fuel tank, and then you take the pipe off onto the side of the engine, which goes onto the lift pump, and then you sort of pressurise the pipe back towards the fuel tank with just an inline hand pump like you get on an outboard. Put a bit of pressure in there, and if there's any weaknesses in that fuel system, then it will leak air out, or you'll see fuel come out. It's quite a good trick to do, because otherwise it's very hard to see where there's an air leak. So you need to be a little bit careful with whenever you change your filters. Another type of pump is actually this type. So more modern diesel engines and some different makes of engine will actually have a fuel filter on the engine. Most engines actually do have a fuel filter on the engine. The point is some will have this pump on top of it. So rather than the lift pump on the side, the actual pump to actually bleed the engine is actually here. And it's just, you just pump that up and down like that. It's a very simple device. And if you've got a Volvo engine, the D1, D2, D3, D4, D6 all have these pumps. And a lot of other engine manufacturers have a similar type of pump as well. And so this is actually a very easy system to pump the fuel up through, and there's a bleed screw on the top to get the air out. So the air will perforate from, you loosen this screw, keep pumping this till fuel comes out, and then you can do it back up. And that's the engine blade. It's quite simple. But with this, you can actually tell a few things. So as you can see, I'm pumping it up and down. Now, eventually, this should get hard to push down. So I shouldn't be able to push it down anymore. And that means the fuel's come up through here and it's gone down the system. And because I can't push it down anymore, there's plenty of pressure in there. So then that means it's bled up and there's plenty of pressure in there to start the engine. If it keeps pumping up and down and never goes hard, chances are there's air leaking into the system. It could be as simple as you run out of fuel. It could also be that there's an air leak in the system. So if you know there's plenty of fuel and it just won't ever pump enough to go hard or fuel to come out of there if you're trying to bleed it, then chances are there's air getting into the system. So I suspect out of fuel or an air leak. But the other thing is that if you've got a blockage, so your engine, the symptom of you having a fuel blockage is actually the engine revs slowly diminishing. And they'll get lower and lower and lower and lower, and eventually the engine may cut out. And then after a few minutes you'll be able to restart it, but then you'll go again and very quickly the engines will die out again. And then after a few minutes you can restart it and then it will do it again. That normally means you've got a fuel blockage, because that is actually the fuel system vacuuming. Because of the blockage, the engine is trying to suck the fuel through, it can't, so it's vacuuming, you're getting less and less fuel, and then it cuts out. Because it's a vacuum, this actually sucks itself down flat and holds it there. So if the engine's running and you see this go like that and then holds itself down flat, there's vacuum as a blockage. So we need to be checking for a blockage. And the blockage won't get past the first filter. So normally the water separating fuel filter, if it's got a paper element in it. So you need to be looking from that element. So the obvious thing is the element's blocked, back to the fuel tank. And you could end up with some bug trapped in somewhere like this. It could be as simple as someone's turned the fuel off, and that would do the same thing and you haven't realised. So check the obvious first and then go from there. So on from fuel, there's obviously a lot to the fuel system, but that's the most common cause. But going beyond that is actually mechanical failure. So actually the engine internal is actually breaking. Now, in all my years, I haven't really seen an internal component of the engine just decide to break for no reason. It's always the other things that cause it. So a bad overheat, a lack of oil because you've got an oil leak that hasn't been rectified, or lack of maintenance. So the oil filter hasn't been changed for so long, it's stopped pumping oil around the engine. So really mechanical failure is pretty uncommon, but it's more common if you don't look after the rest of the engine. So it's about preventative. You really need to look after the engine to prevent obviously a mechanical failure. Best things you can do is look after your cooling system and look after your engine oils. So it's regular oil changes and regular fuel system checks, and then obviously checking the basics, which we'll go on to in a sec. So the way to avoid mechanical failure is looking after your engine, servicing, making sure fuel's in good condition. And the final common call is actually fouled propellers. Now we get calls, or we used to get calls with fouled propellers for basically ropes is the most common thing. So, and normally the most common type of rope is actually your own, believe it or not. So we do get nets, we do get fishing line, with fishermen dropping lines over and nets over, but actually the most common is your own mooring lines or your own sheet lines from your sailing. So quite often you'll see the sheet lines coming down the side of the boat when you're actually seeing other boats going along, and of course if that is loose and drops into the sea, it gets dragged under around the propeller. Also mooring lines stowed on the bow. Quite often you won't notice them slip off under the boat, next thing around the propeller. So you really need to be careful with fouled propellers from the point of ropes, especially your own, so always stow your lines away. But the other thing which probably be common at the moment is actually propeller being covered in coral worm, barnacles, seaweed, this, that and the other. And what will happen there is because the propeller relies on the water flow over the blades, and the blades are actually covered in a coral, this is actually a propeller covered in coral worm, a few things will happen. One is the water won't flow over the blades, so you won't get the boat getting pushed through the water very much at all if it's got heavy contamination. And that's because the water won't flow through the propeller and it just throws it all over the place. So you'll get a very slow speed. The other thing as well, if you remember when you clean your propeller, it's nice and smooth. Because it isn't nice and smooth and there's loads of coral and barnacles and everything stuck to it, it creates a lot of load. So the propeller actually really struggled to turn through that water. And the problem is with that, it puts a lot of load on the engine. So you'll have two main problems. Is the engine won't rev up, but in revving up, you'll get a lot of black soot out the back, and that'll be black soot, you might be just see it on the water or in the form of black smoke. And also for the normal revs that you're able to get to, you're actually not going very fast. So if you would normally at those revs do 4 knots, you probably might be only doing 2, 1.5, something like that. And that would be a good suggestion if you're not getting any boat speed at the revs that you're getting to and black soot on the water, then you've got a fouled propeller, normally with barnacles, coral worm, seaweed, something like that. So the only way to sort that out is actually get the boat lifted and cleaned, or get a diver down to clean it off, or dry it out somewhere if you're able, and do it yourself. So that's the best way to sort out your foul propellers. And you don't really want to carry on if you are getting a lot of black soot, black smoke out the back, because it is overloading the engine. You need to reduce the engine speed enough that you're not getting that. And of course then you probably have no speed at all. So it's best to try and get it sorted out as soon as possible. Alright, so let's just move on from that. So the other things that you need to keep an eye on is actually your engine instrumentation. Now, don't forget, it's these lights and these alarms which tell you if there's anything going on. And the 3 most commonest type are actually oil pressure, charging, and overheating. So most engines will have a minimum of those 3. Now you can get an awful lot more. So cars, for example, now they have warning lights for everything. They tell you the bulb's gone, things like that. But if you've got a more modern engine, diesel or petrol, then they may well have an engine management system on them now. So you have lots of sensors around the engine, there's lots of solenoids and relays, and that will actually indicate warning lights if there's anything goes wrong with those systems. But your most important ones are actually your oil pressure, your charging, and temperature. So we need to make sure that our engine instrumentation works. So it's extremely important. For example, if your oil pressure alarm or light doesn't work, there's nothing actually going to tell you if you suddenly lose oil pressure. So for example, if you have an oil leak and don't realise you're using the engine and the engine oil runs out. Now normally the oil alarm would sound and you get a red light come on to tell you there's no oil pressure. And it'll be a constant sound, just a constant buzzing to tell you. But if that doesn't happen, then there's nothing that will tell you that the engine has lost oil pressure. And the problem is with oil pressure, it relies heavily on protecting the internal bearings of the engine from damage. And without the oil pressure, the engine will start damaging itself straight away. Just let me just show you something. Okay, I should have got this out earlier, but this is a piston. So it's a piston at the top, and then we have a connecting rod, and then this circle attaches onto the crankshaft of the engine. And inside here, 2 flat pieces of metal. Now the crankshaft will turn and push the piston up and down. It's probably not great. So the crankshaft turns in here, and remember the engine is turning one full turn, and it's doing 600 revolutions a minute, and up to about 4,000 or 5,000 a minute at full speed. And the problem is the actual bearings are just these 2 flat pieces of metal, and they're not needle bearings or roller bearings or anything like that. They're just 2 flat pieces of metal where oil pressure is forced into the gap between these flat pieces of metal and the crankshaft, and that oil pressure just keeps the 2 metal surfaces apart. As we know, if 2 metal surfaces rub against each other, create an awful lot of friction, and that's exactly what happens if you lose oil pressure. The 2 metal surfaces connect, and then they create a lot of friction very quickly, 600 revolutions a minute up to 4,000, 5,000 at high full speed. and it generates a lot of heat. The metal expands with heat, the joints tighten up, they lock themselves together, and they can physically damage these components. And I've seen these connecting rods snap and pistons come out the side of the engine. So it's really important we look after our oil system and make sure that our alarm systems work. So it can be the difference between a fixable fault and major engine failure by your instrumentation actually working. So all your instrumentation should be checked before. So as you turn the ignition on, your light should come on. And you can sometimes have an alarm test button that's on your engines, but there should be some way of them self-testing themselves, or you should have a physical check. So you always should check your engine manual, and your engine manual will tell you the normal operation. And of course, if you've had the boat for a while, you should know the normal operations. You should know what lights there normally are. And so you'll be able to spot then now when you turn the ignition off if any of them are missing. And if they're missing, that circuit isn't working. So the next time you know the engine's overheating or the oil pressure's going is when you have a mechanical failure, a more serious problem. So monitor your instruments. So a lot of boats will have temperature gauges, they'll have oil pressure gauges, they'll have voltmeters. So if you're lucky enough to have these, you can constantly monitor them. And remember where they normally are at the engine speed you're doing. So suddenly if you're always running at 90 degrees on your temperature, suddenly it's at 95. It's not enough for the alarm to come on, but it's enough for you to notice, oh, hang on a minute, I'm normally run at 90. Why am I now running at 95? Maybe I should check my water strainer, there might be some weed in it. And it preempts the fact of the engine overheating, and then obviously you're causing a problem. So it's really important that these gauges work, and that you check they work before every journey. So record where the gauges normally are, normal operation. So when you know everything's working right, just check how everything normally works. And then if anything differs from that, then you know instinctively there's a problem. So in going on from that, you should do regular engine checks. Now regular engine checks are before starting. I mean, a pilot would never take off on an aeroplane without going through a checklist. So it's very good to get your own checklist together of things you need to put on there. Now things that you probably put on would be make sure your battery switch is on, check your engine oil level, check the alternator belt tensions or any other belts. You can have more than one belt. And a good way to check the belt tension is actually, this is a belt here. There's different types of belt. This is a more modern type. It's a flat belt which sits on top of the pulleys. And what you want to do is find the longest run of belt between the pulleys and actually just see if you can move it more than ½ an inch in total either way. And if you can, then the belt is actually needs tensioning up a little bit. You shouldn't over tension belts, but they shouldn't be under tensioned, otherwise they'll slip. Quite a common way to tell if a belt is slipping if you're unsure is actually if you've got the alternator, if you know what an alternator is, it has fins all the way around the pulley. And if you can move the pulley around with one finger without the belt turning, then you need to tighten it up, because exactly the same thing will happen when the engine's running. But a good way is ½ an inch in total movement on the longest part of the belt. On these flat belts, you can actually twist them, and you shouldn't be able to twist them more than 90 degrees. That's another way, so you shouldn't be able to twist them more than 90 degrees. That's another good way to tell. But we need to check for the belt tension. Check your raw water strainer before every trip, because we don't really check it once we've finished a journey. We just sort of lock the boat up, turn everything off, turn the seacocks off, batteries off, and off we go. But we don't know we didn't suck anything in just as we're parking the boat. So check the water strainer before every journey. Check you open the seacocks, and check the bilges are nice and clean before you set off. We need to keep bilges clean. It's a really good indication of what's going on with the engines. So we need to clean them of oil, fuel and water. So after starting, we're just checking for water flow around the engine. So normally the raw water flow, so we're checking it's coming out the exhaust, and we're checking strainers. Some strainers have a clear lid, we can actually see the water flowing through. There is another trick you can do if there is no way to tell, is that if you can get to the impeller, which we saw on the screen earlier spinning around, it has a metal plate over it. And if you put your hand on the metal plate, it should actually be cold to touch, and that means water's flowing through it. If it's warm or hot to touch, then unfortunately there's no water going through it, and we need to shut the engine down and investigate why. So it's a good way to tell if there's water flowing through the impeller is actually just by touching the plate. If we can't visibly see it, it's hard to see. So we need to check if we've got oil pressure gauges, oil pressure lights, that they go out and the gauges read correctly. And again, the battery light is actually the charging light. So it doesn't tell you the battery condition, it's telling you if the alternator is charging the batteries or not. So that battery light should be on when the ignition's on and then go out to indicate that it's now charging. Make sure you've got no ropes hanging overboard, as we know that's the common cause. And then when you get back, always allow the engine to cool down before you turn it off. So never, after you've done a hard run, is actually just come down to a stop and turn the engine off. In fact, I've seen engines overheat because of this, because you stop the water circulation and the water will get very hot very quickly, and it can actually expand and come out of the pressure cap on the engine itself. So allow the engine to idle. That normally is when you're coming back up the river back to your berth. So normally by then it has cooled right down. But if you're ever stopping at an anchorage, always make sure that you let the idle cool for a few minutes first. And then stop the engine and then turn off any unnecessary electrical equipment. Shut your engine seacocks off, and then just make sure that everything is put to bed correctly. And really, if you follow these sort of steps and these regular checks and do regular maintenance, then you'll prevent a lot of breakdowns from happening. But a lot of it is down to you. So we really need to look after our engines and keep on top of what we need to do. Now, there are spares you can keep as well. So spares that we want to keep on board, there's kind of a minimum requirement. So any oils for the engine, so any engine oil, gearbox oil, power steering oil or power trim oils. An oil filter, fuel pre-filters. I normally say carry 2 spare fuel pre-filters. These are the water separating ones. They're actually the first line of defence from any contamination. And if you happen to have contaminated fuel, using a boat for the first time in a long time or first to you, then you can block it up. And then of course once you change it, you may have changed the filter but you haven't stopped the contamination, so it could happen again quite quickly. So carrying 2 of those, you've got 2 chances of getting back before it blocks up twice. 1 engine fine filter would be enough. A set of drive belts, so fan belts, alternator belts, power steering belts, water pump belts, whatever belts your engine has fitted. An impeller, spare rubber impeller, because if you do get a blocked water inlet, we can easily damage it. And this is one that's been completely burnt to a crisp. So you need to keep a good close eye on them. And normally, again, if you can, carry 2 spare impellers. Sometimes you'll replace the impeller but not actually got to the bottom of why it went in the first place, and then it will damage it again. But also, if you happen to have a failed impeller early on in your long trip, then you don't have another spare for the rest of your trip. So carry a couple of spares. Any fuses that you need around the engine, obviously depends on engine type, and coolant. And just keep pre-mixed antifreeze. So water, so coolant is basically antifreeze and water mixed together. Normally a 50-50 split. And I'll normally always pre-mix it. We'll buy it pre-mixed. Then you know that you're putting in the right mix when you top up. If in an emergency, always top up with fresh water. So any water is better than no water, but ideally put in a coolant. Okay, if you do top up with fresh water and your system is really low, then you need to obviously drain that out and replace it with coolant as soon as you can. But certainly to get you back, it will do. And with that, you should carry tools just to do really the jobs that you're going to undertake yourself. Carry them in a waterproof case or a dry area. And sometimes tools on board you don't use for a long period of time. Hopefully you've been looking after your engine so you don't have too many breakdowns, but they do tend to corrode and can rust up, and so when you do go to use them, they're useless. So keep them, look after them, keep them in a waterproof case or a dry area. And torches, you need a good torch. Doesn't matter how sunny it is outside, it's always dark in the engine room. And lots of paper towel just for collecting messes, protecting the areas around where you're working, putting under fuel filters when you bleed them. Very good. And gloves if you can get them. So I'm even having trouble getting gloves myself at the moment for doing engineering work, but gloves, torches and paper towel. But when it comes to fault finding, it can be difficult and frustrating. You know, you need to be though level-headed. So don't ever try and fault find in a panic situation. You're much better getting help before you try and solve an engine problem, or at least calling somebody to tell them you're in trouble, and maybe you're trying to fix the problem, but I may need your help. And the RLNI or a breakdown service certainly won't mind you doing that. In fact, they'll probably offer to still come on their way whilst you try and solve the problem, but you just let them know if you fix it. And straight away then, knowing that someone's on their way or coming to help, your level of stress and anxiety will drop. Or at least knowing someone is where you are, and give them your position, tell them where you are, and then keep them informed. So don't ever try and do it in a panic situation, because you'll go wrong. I promise you that. Approach problems logically. So if you do have an overheating engine, is it a raw water problem or a coolant problem? And so approach them logically, and always be methodical, but check the obvious first. Is the seacock on? Is the strainer blocked? Is there a loose pipe or the fan belt's loose? Is the fuel shut off? Check the obvious first, and then proceed from the simple fixes to the more complex. And also recognise when to stop. And it sort of goes back to asking for help. I always, in the breakdown days, used to have a 10-minute rule that if I had no idea what was wrong in the first 10 minutes, then I'd tow the boat or take it back to where it needs to be. And you should do the same thing, because when you start working on an engine, it's very quick to actually lose time. And you may have other people on the boat, you may be in a choppy sea, you may be anchored somewhere, the weather might be changing. You really need to, if you don't have a clue what's going on with it within the first 10 minutes, that's the time to ask for help. And then someone can be on their way. You may well carry on doing it, like I said before, but then at least someone is coming to you. Because don't forget, it might be getting dark, and the last thing you do is want to be calling somebody for help 2 hours later when someone could have already been with you and towed you back. So that's kind of my talk for today, and I hope it's been useful. And my company is Parker Marine Services, and my name is Jonathan Parker, and I also do one-to-one tuition on people's boats. Obviously, during these times of social distancing, that is difficult, but as the social distancing is relaxed, I'm quite happy to do one-to-one tuition. I can teach you how to service your engine, or even just how to do regular engine checks and what to do in certain breakdown situations. So please contact me if you need any further help, and I'm always on the phone even if you just want some advice. So thank you for this, and I hope you enjoyed it.